There's a ton of hype around innovation, entrepreneurship, commercialization. Thousands of books are written every year about this topic. But let's cut through that hype and focus on what really matters. When we're innovating, when we're commercializing, when we're being entrepreneurs, we're engaging in problem solving. That's the thing that all of us do when we're taking on these activities. And so in order for us to become better at innovation, at entrepreneurship, at commercialization, we want to become better at problem solving. And thankfully, we have 50 years of literature in the cognitive sciences, in psychology, in sociology, and economics that has tried to make progress around how people can be effective problem solvers. And one very powerful approach is to think about problem solving as a search process. You're searching through a landscape for solutions. And this approach is very helpful for us. And the way to think about this is that a searcher, you as an innovator, as an entrepreneur, has to have two things to be effective. One is a perspective, like how you represent the problem you're going after, how you're defining the landscape that you're going after. And then secondly, you need a heuristic. How do you then find your way through that problem-solving process and find an appropriate solution? How do you traverse this landscape? So innovators go through creating a perspective and a heuristic pair when they are solving problems. So let's now make this fairly concrete and specific and make this accessible to us. I want us to go back to your high school days when you were learning trigonometry and you were learning various ways to do math and algebra and geometry and so forth. One of the things you might have learned about has been like the Cartesian coordinate system. Really what was being talked about was how do you represent objects in what's known as Euclidean space. Now, there are two different ways to represent an object. You can use Cartesian coordinates, if you remember x and y, to represent an object. Or you could also use what's known as polar coordinates. You could represent an object by a radius and an angle as well. So depending upon the object you're trying to represent, you might have a different coordinate system. You might use a Cartesian system to represent a rectangle. It's fairly simple and easy to do. But if you were to represent a rectangle through polar coordinates, it'd be very difficult. Similarly, if you took a circle and tried to represent that through a Cartesian coordinate system, it'd be very difficult, but it's very simple through the polar coordinate system. What this is telling us, this nice toy example is telling us, is that any problem, any technology in what we care about can be represented in multiple different ways, multiple different perspectives, and multiple different heuristics. And so what may be tough and difficult in one perspective and heuristic pair may actually be super easy to solve in a different perspective and heuristic pair. And so for entrepreneurs, what we want to do is find ways to generate multiple perspectives and heuristics on the same technology, because the choice of the perspective and heuristic that you're going to go after is going to, in many ways, define the difficulty that you face. And certain problems could be novel and difficult and even unsolvable with one perspective, but then fairly easy in a different perspective. The Euclidean space examples of the power of alternative perspective heuristic pairs shows us how some problems that are hard in one perspective heuristic framework can be relatively trivial in another perspective and heuristic framework. So let's go beyond the toy example of finding objects in Euclidean space, and let's look at the world of life sciences. Here, you can imagine again that different perspective heuristic pairs will be very helpful in solving core problems in life sciences. If you think about the world of neurology and brain problems, we can model the brain as a biological organism, we can model the brain as a chemical engineering organism, or even we can model the brain as an electrical engineering problem as well. Depending upon the perspective heuristic that we apply, some problems will be easier in the electrical engineering framework versus some will be easier in the biology framework. And in fact, we see this happen quite a bit in epilepsy. In epileptic treatments, you can do electrical stimulation to alleviate some of the symptoms, or you can take drugs that affect both your chemistry, your brain chemistry, as well as your biological features to help alleviate epileptical episodes. And so in this case, what we see are, depending upon the perspective heuristic framework, we can be more or less successful in solving problems that people face. Another example in life sciences comes from synthetic biology. Here, protein folding is a major bottleneck when it comes to making progress in discovering new drugs that impact the human body. And oftentimes they're faced with large bottlenecks for computational processing. A paper published in 2005 showed that methods that were well understood in material science could be taken and ported over to synthetic biology to drive massive improvements in performance, orders of magnitude improvements in performance. This happened because a postdoc saw some stuff in a material science class. He was taking that as a side project and took those methods that were commonly used there, and then when he brought them over to protein folding, had a massive impact. Here again, what we see is the power of an alternative perspective heuristic framework being applied to within the synthetic biology world, importing something from a distant field and bringing it in to the field that you're participating in. Let's go to one more field. Let's talk about something far away from biology. Let's talk about the world of finance. In finance, there's a history of importing perspectives and heuristics from physics and engineering to solve tough finance problems. So in 1959, Osborne showed that the market could be best understood through methods of Brownian motion. Brownian motions is a core part of how we understand physics, and Osborne brought that perspective to understand financial market data. More recently, Black-Scholes won a Nobel Prize for their option pricing equations. And their initial cut on this option pricing work was very complicated and hard to solve. They met some folks in mechanical engineering, and they looked at those equations, and those guys said, oh, this is basically a heat mass transfer equation, and here's how to solve the problem. And so what was very tough for them with one perspective heuristic framework became easily solvable with the heat mass transfer framework that the mechanical engineers taught them. All of these examples show us that entrepreneurs are going to be better off by systematically thinking about perspectives and heuristics for the seeds that are being created that they have available to them, and then use that to generate new options in the marketplace.